Hey guys, welcome to Algebra 1B. Today we're looking at problem set 104, and in this lesson we are looking at what's called abstract rational equations. Now, rational equations we've dealt with. Rational means fractions, equations means we have an equal sign, and we're going to solve for some variable or some letter. Okay? We're going to have fractions in our problems. That's where this rational term comes from. But this idea of abstract, when we're talking algebra, this term abstract means our solutions are not going to have a very specific answer in that it's not going to equal a single number. An abstract equation has several different variables in it. So, for example, you see the problems here on the screen. We have several different variables within one problem, and we're going to solve for one of those letters, but our final answer is going to have a bunch of other letters in it, which makes it abstract. It's not a very clear answer. So kind of think about abstract art. It's not a real clear picture of something. It's kind of distorted, kind of twisted. That's what these problems are going to look like. Our final solution will solve for one letter, but our final answer is going to have a bunch of other letters mixed in there. Okay? So these problems, since it says rational, we're going to have fractions to deal with. So the very first thing, before we even look at what letter we're going to solve for, I want to go through and eliminate the fractions out of the problem. Okay, we've done this before on some other rational equations, and that's where we look at all the denominators, we decide what a common multiple would be of those denominators, or common denominator, and we multiply through by that multiple, or that number, and that cancels all these little fractions. Well, we're going to do the same thing with these problems. That's your first step on all these problems, is eliminate the fractions. So this first example, I'm going to label this number 1. So we're going to look at the denominators. To help, I'm going to look at x as a fraction also. And I need to decide, what would my common denominator be? Well, I have a b, and I have a d, and I have a 1. The 1 really doesn't do anything, but the b and the d, those two will make up my common denominator, or common multiple. So I'm going to use that term BD, and I'm going to multiply that to every term in the equation. So I go in here and I multiply by BD here, and BD over there. Okay? Multiplying through by that common denominator allows me to cancel the fractions in the equation. So when I multiply to the A over B, BD times A over B, the b's cancel. I'm left with a times d, which is AD. Plus, in the second fraction, c over d times BD. The d is going to cancel with the d, and I'm left with b times c, which is BC, equals. On the right side, since I have a 1 on the bottom, nothing's going to cancel, and I have x times BD. I'm going to put those in alphabetical order, BDX. All right, so no matter what I'm solving for, no matter what letter it tells me to look for, I need to get rid of those fractions. So that's my first step. Now I look back at the problem, and it says to find b. Well, I have a b in that term, and I have a b in that term. My next step is I want to get all the terms that have b in it together on one side of the equal sign, and anything without a b on the other side of the equal sign. So since I have a b on the right side of the equal sign and a b on the left, I'm going to bring the one from the left over to the right side. And I'm going to leave this AD on the left side by itself. So to move this BC over to the right side, what do I need to do? Well, since it's plus BC, to move it to the other side, I'm going to subtract it. Subtract BC from both sides. So on the left side, I have an AD equals. On the right side, these guys are not like terms. There's all kinds of crazy variables there, so leave them separated. BDX minus BC. Okay? So I have the two terms with B in them together on the left side. The non-B terms are on the right side by itself. That's what I want. Okay? So my next step, I'm trying to get just a b by itself on one side. Since these two terms on the right side both have a b in it, I'm going to factor that b out. And by factoring it out means I'm going to pull it out front. The right side is going to stay, or I'm sorry, the left side is going to stay AD. But on the right side, since I'm pulling that b out of both terms, I got to look at what's left. I'm left with a dx minus a c. Okay? So now we're a little bit closer. We have one last step to get this b by itself. And that is, I need to get rid of this dx minus c. Well, I need to look at what operation is happening between b and that group of parentheses. Well, they're being multiplied. I need to undo that multiplication. So to undo that, I'm going to divide by that dx minus c. And I need to divide both sides by dx minus c. So these things cancel on the right side, which leaves me b, equals on the left side. I cannot do any canceling, any reducing because I have that subtraction, but I'm left with a d over dx minus c. And that is my abstract answer. It's abstract because b equals some weird stuff. It's got a whole bunch of letters in it, okay? If it doesn't equal a single number, it equals a bunch of stuff. That's where the abstract thing comes from. All right, so I got two more problems here, and let's see what we can do. Again, step one. I'm going to label this number 2. On problem number 2, step 1 is I need to eliminate all the fractions. It doesn't matter what variable I'm solving for, I want to eliminate the fractions. To do that, we decide what the common denominator would be. In this case, I have an m and a b and a 1. The 1, again, doesn't do anything, so m and b. That's what I need to multiply every term in the equation by. So I'm going to multiply by an mb, mb, mb. Okay, now we go in and we cancel the fractions. That's the whole reason of multiplying by that common denominator. So in this first fraction, 3z over m times mb, m's cancel. I have 3z times b. I'm going to make that 3bz plus, in the second fraction, n over b times mb, b's cancel. I'm left with n times m. I like them alphabetical, so that's mn. On the right side, nothing cancels. So I put it in order b, f, m, alphabetical. It doesn't have to be, but that's kind of a standard practice to use. All right, so I got rid of all the fractions. Now I look at what variable did they want me to solve for. Well, in this case, it's b again. So I need to get all the terms with b in it by itself on one side. Now we got choices here. I have a b on the left, 3bz, and I have a b on the right, bfm. I need to get them together on one side and that mn, the non-b term, by itself on the other side. If I were doing the problem, I would move 3bz over to the right side. So this is positive 3bz, so to move it, I'm going to subtract 3bz. That leaves on the left side, mn equals. Now, bfm and 3bz, are those like terms? No. So we leave them separated. bfm minus 3bz. Okay, so think about the steps we did on the first problem. We got our b terms together on one side, non-b's on the other side. My next step is I want to factor out that b. Whatever it is I'm solving for, I want to pull it out of those two terms. So I'm solving for b, so I factor out b. I look at what's left. When I pull b out, I have an fm minus 3z. And that equals still mn over on the left side. Okay, I got one more step. I need to finish getting b by itself. So I need to get rid of that group, fm minus 3z. To get rid of it, I divide it off. Divide by the whole group, both sides. So they cancel off on the right side. That leaves b equals, on the left side, mn over fm minus 3z. Again, I cannot do any canceling. Don't try to cancel the m's or do anything fancy like that. Because of the subtraction here, I can't do any canceling. So this is my final answer. Okay? I got one more question here, or one more problem. I'm going to kind of make some room here. Move this down a little bit. So, this one's a big mess. We got a whole bunch of stuff here. We got to look at eliminating the fractions first. So, something that catches my attention, I'm going to change colors here. M needs to be a fraction, and y needs to be a fraction. I like to look at everything as a fraction first, and then we can eliminate it. So I look at all the denominators. Again, these ones, they really don't do anything. It's the other stuff that I need. I need an n and an x. So what are we going to multiply by? Well, the common denominator, common multiple would be nx. So make sure you multiply it to every term in the whole problem. Both sides of the equal sign. Whoops, that's an n. Let's just erase that. nx. Okay? Multiply to every fraction, every term in the equation. Both sides of the equal sign. Now we get to cancel. So on the first fraction, n is gone. I'm left with a times x is ax. Minus. Does anything cancel in the second fraction, second term? Since I have a 1 on the bottom, nothing's going to cancel. I'm left with m n x. Plus, third fraction. I have an x on the bottom. That's going to cancel. So I have 5kn equals. On the right side, I have a 1 on the bottom. Nothing's going to cancel. So I have nxy. Okay, so next step. Now's where I look at what I'm going to solve for. I'm trying to solve for n. So I want all the terms with n on one side, non-n's on the other side. So when I look at it, I have an n in there, an n there, and an n there. I can do two different things. I can bring them all over to the left and send the ax over to the right, or I can move them all over to the right side and leave the ax on the left. It really doesn't matter. It's just whatever your preference is. And if you watch checking answers with your answer key or in the back of the book, you may get slightly different answers depending on which choice you make right here. So you could have two different answers that are correct, but look a little bit different. So again, it doesn't really matter. What I would do is I would send everything over to the right side. So I'm going to add mnx, and I'm going to subtract 5kn. Now, it's getting kind of messy here. So this is what I have. I have ax equals, on the right side, I have nxy plus mnx minus 5kn. Okay, be careful on that. There's a lot of stuff going on there, a lot of easy things to miss, and if you don't write very neat, you could really mess things up. So be careful. All right, so we got all the terms with n on the right side, non-n's on the left. Next step is I want to factor out that n, that thing that I'm solving for. So I pull n out of all these terms. That leaves, on the first one, it leaves an xy plus mx minus 5k. All that equals ax. Let's move this up a little bit. Next, I'm trying to finish getting that n by itself, so I'm going to divide by that group. xy plus mx minus 5k.